Yeah, so my name is Paul Blount, for anyone who doesn't know me. I work as a portfolio director with Coillte, and I've been chairing the 70 by 30 committee for the last number of years. And I've been given the task, I suppose, in 20 minutes to explain how do we actually do this. And to just forewarn the chair, it might take 25. And I hope everyone can kind of bear with me. Sorry, which of these? Green one. Yeah, so maybe just to begin, just like what is the role of the 70 by 30 committee? So we were given the job, I suppose, to generate the evidence basis for a 70% target and then support the delivery of that target. And the first question is that a credible proposition? So there was a lot of work done in the early days of it by a small number of people within IWEA, and that ultimately culminated in the Baringa 70 by 30 study. And that showed that not only is it credible, but if we can deliver onshore and offshore wind at reasonable cost, it can be cost neutral for consumers. So it concluded, I think it was €60 a megawatt hour for onshore wind, 70 for offshore. And at those price points, it becomes cost neutral. So then the question is, can we achieve those cost points? And we're going to see a presentation that Dave has already referred to later today from Everose, where they basically demonstrate how those prices can not only be achieved, but can be beaten if you deploy modern turbine technology and you're operating in a kind of a sensible policy and regulatory environment. The next question, and there's a lot of good work going on in the Community Engagement Committee on this, is will it be supported by society? And what we find, ESRI have conducted national surveys, and you see that on a national basis, there's actually a lot of support for the development of wind. Like obviously within individual communities, it's more challenging. I think there's a key role for us there. There's a lot of work to be done to debunk some of the myths around wind, to tackle the real issues, to address the real issues and do better earlier engagement and then share in the benefits of wind. So the €2 megawatt hour being mandated under RES, to kind of share the spoils, I suppose, of the industry with the communities in which we build, and then these community investment opportunities as well. To try and bring society with us is going to be a key part of it. And what I'm presenting on today really is how do we do this in just 10 years? And to tackle that, we established the 70 by 30 implementation plan working group within the committee. And this is just to give you a flavour of some of the companies that are on it. So there's a very, very strong cross-section of developers, utilities, planning experts, grid experts, OEMs involved, and both of the semi-state companies that are operating in this space, plus a huge amount of support from the IWEA staff as well. So between David, Noel, and others, there's been a lot of effort put into this piece of work. The first question is, what are we actually trying to do here? 70% RES-E in 2030. That's the conventional generation profile you get to. That's the renewable generation profile you get to. And what you're seeing there is an industry where there's a huge amount of growth forecast in demand for electricity over the decade. And what that means is we are trying to build double the amount of renewables in the next 10 years that we did in the previous 20. So that's just to kind of give you a sense of the challenges. So like what we are seeing here is this is real ambition. I believe it's achievable, but that's just to put it in perspective. So that brings you on to the question of what does time look like? So time is of the essence here. We've a limited amount of time to do a hell of a lot. What does time look like today? So if you take, I'm calling it a typical project. There's probably no such thing as a typical project. But you're certainly looking at 2 years minimum for bird work, for planning applications. So say 2.5 years. To make a planning application. When we look historically at the blended average consenting durations, it's taking up to 2 years by the time you consider appeal periods, judicial review periods, and blending onboard Penola decision or SID applications and local authority applications. You then go into a grid offer process. I mean, I've worked on projects that are waiting 6-7 years to get a connection offer. If you take an ECP type rule set, you'd certainly expect that could easily take 3 years to get a connection offer from the time you get planning. You then, in today's world, are probably looking at, in many cases, trying to get a second consent for your grid connection method. After that, there's a new step now where you have to secure route to market. So previously, when we were working under a feed-in tariff regime, once you had planning and grid, you effectively, if you were commercially viable, you built, you now have to secure route to market, and then you're into your finance and build stage. So like as you look at that timeline, you can kind of see that's adding to 13 years. You're looking at 9 years of work and high-risk development just to get to the point where you're able to bid into an auction. But if you scan through it and look at where are the easy wins, well, if you could do parallel consenting of the grid, so solve the issue of private ownership of public road, better engagement, earlier engagement with the SOs to understand your connection method, you could, in parallel, remove that 2 years of time straight away because that now gets consented with the wind farm. Grid offer processes, no reason in the world why that shouldn't be shortened to 1 year. And with more frequent auctions or an active corporate PPA market, getting the route to market down for the good projects down to 6 months is very much achievable. So you can kind of see relatively quickly how you could take that 13 years and almost cut it in half quite quickly. But, sorry, the other point here is this is a timeline where we're assuming the transmission system is able to take the project. And sorry, I've skipped through the animations there quickly, but the point is, when do we start, for projects that the transmission system today isn't actually able to take them in a commercially viable way, the constraints are too high, when do you start work on the transmission system development? Do you do it in parallel with the wind farm development, or do you wait until you see projects that have planning and grid, and only then do you start thinking about what the transmission system needs to look like? And you can see there on that timeline, you could easily lose 5, 6, 7 years in that process, and we just don't have that kind of time. So to try and tackle this across, I suppose, the entire portfolio, the national portfolio of development projects, we built this pipeline analysis tool. And we began with the developer survey that David referred to. So we surveyed the membership to see where are your projects, what's their current status, are they early stage development, are they more advanced, is there board work done on them, are they in planning, do they have planning and grid? And for the early stage projects, then we had to come up with a figure for an amount of attrition before you even go into planning. So depending on a variety of factors, a lot of an early development stage pipeline actually falls away before you even get into planning. But that then generates the pipeline of projects that are being pushed into the consenting process. And with the consenting process, we were modeling, what's the split between strategic infrastructure projects, local authority applications, what success rates are you seeing in both of those routes, and what's the blended average consenting duration. And that then, through the model, generated a number of projects that were being thrown at the grid offer process. And for the grid offer process, we were modeling batch size, batch frequency, and the prioritization rule sets being applied to the projects. We then looked at the transmission system, and this was one of the trickier areas, but the grid experts within the group identified an amount of capacity in each county that exists today. And as the projects emerged from the planning and grid process, that capacity was allocated to those projects. And as the grid became full, subsequent projects, we started modeling varying degrees of delay. So that's looking at available capacity and then applying delays when full. We then look at the route to market, and for the route to market, we're modeling a degree of oversubscription. So assuming the department want to see competition in the auctions, not everyone can be a winner. So we modeled competition and we modeled frequency of the auction process. And then obviously the projects that emerge and secure route to market, you're into the finance and build stage. So what we then did is we took all of the kind of business as usual assumptions and fed that through the model, and that generated an output, which was the megawatts of projects that were consented in each year and the megawatts of projects that get energized in each year. Then we looked at 8 improvements to those business as usual assumptions, and we applied them one at a time, and we measured to what extent does that improve the megawatts being built in each year, being consented in each year and being energized in each year. And yeah, that kind of gave us our answer, I suppose. So what I'm going to run through now is the analysis of that. In the time available, I can't go too deep into some of the things that move the dial, but I'll try and just touch briefly on it. We're going to put this into a final report where we'll write up the detailed, much more detailed steps as to how you actually move the dial on these input assumptions. But so starting with planning consents, so I've just kind of drawn a line there, which would be the absolute minimum number of planning consents you would need, assuming no attrition post-planning, so that if you built everything that got consent, we'll be roughly at about 4.2 gigawatts by 2020, so we're going to need another 4 gigawatts by 2030. So that's kind of minimum figures. And in the business as usual world, where we applied all the business as usual assumptions, and I'm listing those there on the right-hand side of the graph. So we were applying 33% attrition to the development pipeline before it even goes into the planning process. We're seeing relatively low SID success rates when we look historically, and then the blended average consenting duration was 1.9 years. We then looked at reducing the pre-planning attrition, and as I say, there'll be more details on how the steps you might take to do that in the report, and that obviously moves the dial a bit. We then looked at SID success rates, so there's a few lessons for industry. It's a relatively small data set of SID projects, but there are a few lessons from industry that would probably drive that up anyway, but there's also some policy asks we're looking in terms of meaningful engagement with Bord Pleanála at an early stage in the SID process that would get the SID process heading towards a similar success rate to the local authority process. And because the SID process is faster, if you've got a higher success rate in that process, that brings down the average consenting duration. We then modelled quicker decision timelines from Bord Pleanála, And what you're seeing there is not so much of an improvement at the end of the decade, because by then the whole pipeline is getting consented. But you'll see in some of these earlier years, there's a material benefit to those faster consenting durations, and that becomes very important when you're trying to hit these intermediate targets. So then, moving on to energisation, and it's important to note that all of these measures build one on top of the other. What we saw is the planning improvements on their own didn't really result in any improvement in the megawatts energised, because you're hitting other bottlenecks in the system, so nothing actually gets built, even though you're consenting quite a lot more. So in the business as usual assumption, so this is before we do anything, but it's very similar to what you would see after those first 3 steps have been employed. We're getting to a little shy of 5.5 gigawatts with these business as usual assumptions. So it's let's say an ECP1 style rule set for ECP2. No parallel consenting of the transmission system, needing to get a second planning permission for your grid in many cases, and then a 2.5-year finance and build period. First thing we did was we fixed the ECP process. So this is actually doing what CRU were already talking about doing, which is prioritising the first 25 projects based on scale. There's other discussions ongoing about grid following funding, which potentially would have at least as good an effect, or possibly better. But there's a few complexities to actually getting that to work. But that would at least achieve this. This is the tricky one. So this is the parallel development of the transmission system. So here we took a little bit of a leap, and this is an area where we'd need to engage much more with EirGrid to kind of understand how you achieve this. But in the model, we're not modeling perfection here, but we're assuming 70% of the projects don't face a significant delay because the transmission grid isn't there for them. 20% we allowed a 2-year delay, and 10% we allowed a 4-year delay, and that kind of gets you to that level. Then we implemented parallel consenting of the grid connection, and the benefit here wasn't so great in 2030, but it's quite material in some of these intermediate check-in years, so I'll flag those in a minute, but 2022, 2025, 2027, I think are the intermediate years, and that parallel consenting of the grid connection is very important if you're going to hit those intermediate targets. The next one is actually hopefully quite an easy one. So this was making the long stop dates in the connection offers a bit less onerous. So if you have a very, very tight long stop date in your connection method, you bid into one auction, and if you lose, you're gone. If you've got less onerous long stop dates, you can bid into multiple auctions. You've got more competition in the auctions, and while still maintaining that same level of oversubscription, you're able to build more, because you're just not projects that have taken 5, 7, 8 years to develop. You're not killing them immediately if they lose in one auction. You're giving them a chance to go back and revisit. And then the final measure was just looking at shorter finance and build periods. So that's what we tend to find is that the grid delivery tends to be on the critical path of a lot of projects. And so improvements, and I know ESB are already working on some of this stuff in terms of the IBM Simpler Review, but improvements to the grid delivery process can have a significant benefit, especially in those intermediate years. So again, the benefit it's there in 2030, but it's much more material in some of those earlier years. And that's just going to flag the intermediate targets and see, like that's maybe even where the real challenge is that especially 2022 is going to be very, very challenging, because we're trying to turn a big container ship around where there was a bit of a pause for a number of years. So for offshore, we had hoped to do a similar piece of analysis for offshore, but there's quite a lot of uncertainty still around legacy projects and how they might interact with the new consenting process. And we're not too clear in terms of the degree of competition that's expected in offshore. So it made it difficult to do a similar analysis. But what we can say in offshore is the legislation doesn't exist today to do anything. So if you took a very negative view, you would say, if nothing changes, nothing's going to happen. What's very positive is the Climate Action Plan included a lot of detailed measures, or at least a lot of high-level enabling measures. And the offshore industry will be confident that if they are all delivered on time, the offshore industry can deliver. But in terms of the intermediate targets, so things like how the legacy projects interact with this new consenting regime has the potential to determine whether offshore can actually contribute to some of those earlier targets or whether it's much later. And it certainly requires timely implementation of all of these measures if the new projects are going to make a contribution in time for 2030. That's not to say there's not a value in them being there immediately after 2030. But so the key kind of call us on is the MPDM bill to be enacted, a functioning grid offer regime, and a route to market for offshore as well. They're kind of the 3 key pillars that offshore requires. But what you do see is across both onshore and offshore, there's a number of shared challenges, and I'm going to call out the transmission system in particular. The East Coast study for offshore indicated maybe 1.5 gigawatts could fit onto the grid without too much difficulty. our analysis is kind of showing onshore can do probably something similar, but after that, you certainly need to be developing the transmission system in parallel with the projects if we're not going to hit a wall. Parallel consenting of the shallow connection assets. So this is the point about solving the private ownership of public roads and early connection method information, so that when we consent the wind farm, we can also consent the shallow connection. That's an issue for both technologies as well. And as you scan through it, I'm going to go through these quickly, but grid connection offers, the connection offer long stop dates, grid delivery timelines, route to market, and on board all the decision timelines. They're all shared problems. If you can address them for one, you're addressing them for both. The next one I'm going to speak to, I just haven't touched on it yet, is curtailment. And I'm going to do a Darina Allen on this, because explaining this properly takes about an hour, and I don't have an hour. So there's a link to a YouTube video at the bottom where it's a body of work that myself and Rory Mullen have been involved in, and with support from DCU, and Abo Wind is there because I used to work for Abo Wind. There's a more fulsome explanation of this on that video for those who want it. But I want to call out two things in terms of curtailment that absolutely have to happen if we're going to get to this target. The first is we need to relieve the operational constraints that exist on the system today. So that's about the SNSP limit and the minimum conventional generation. And the second thing is we need to build the interconnectors, and with the interconnectors, we need them to work properly. And I'm going to try and condense a 1 hour explanation now into 2 minutes. So let's see how we get on. So this is, from a curtailment perspective, the first thing we had to do was let's define the problem of integrating 70% renewable electricity onto the grid. So the way we did that is we took, up in the top right corner, the system as it exists in 2020, and we just built wind. So we didn't do anything to integrate it. We simply added wind until we got to 70%. Curtailment goes crazy. We got to 43% curtailment if you did nothing, if you just built wind to get there and did nothing else. I'm going to just go through the next couple of slides, points quickly to skip on to where we got to. So within the Baringa study, we called out a 90% SNSP limit and a 700 megawatt minimum conventional generation. And what you're seeing there is that as a single measure, doing nothing else, not doing the interconnectors, doing nothing else, more or less halves the problem. What we're seeing now, and this is really fantastic to see, is EirGrid have listened to industry, and instead of, they're not even just doing what we asked, they're saying we're going to try and do more than you're asking. And they're saying 95% SNSP. They didn't specifically say what the min-gen level they're targeting is, but it doesn't really make a whole lot of point to go to 95% SNSP if you're not getting min-gen down around 300 or 400 megawatts. That on its own, doing nothing else, solves 2/3 of the problem. So that's a huge enabling measure. That's just a line up for, this is a 100% SNSP line, so kind of the maximum limit if you completely removed all constraints will be the bottom left there. And that's just seeing all those lines together, looking at the various different SNSP limits. The next thing we looked at was looking at kind of what you would do in terms of storage and in terms of interconnectors. And this is what we got. So what we're doing with storage is we're, again, starting with this broken system in the top left of the graph, and we're implementing battery storage first, so 3-hour batteries. And what you find is, because they're energy limited, they get full very quickly, and then they sit there for a very long time, not able to do anything. Eventually they find space, they empty out, but they're just not able to, there's not enough energy capacity in a 3-hour battery to really have a material impact. Now, within the wider presentation, there's a whole bunch of good stuff batteries do, and that's called out in the wider presentation, so we're not being negative about batteries within this body of work. We're just saying what it can do and what it can't do very well. As you start increasing the energy duration, so if you look like 6-hour duration, 15-hour duration, 30-hour duration, and that's on the bottom right of the graph, you're at 3 gigawatts of 30-hour storage, and all you're doing is moving the dial from the 43 down to about 25. And to put that into context, from an energy perspective, that's the equivalent of about 50 Turlock Hill projects. So an insane volume of storage. And this is why when you talk about using storage for integration, you really need to be looking at these more seasonal storage technologies. The likes of hydrogen certainly has potential, but you need very, very large energy volumes to do anything. So when you look at interconnectors, and this is modeling interconnectors in an idealized way, and I would say the storage was also modeled in an idealized way, if the interconnectors can export 100% of the time when there's curtailment happening, that's the benefit of the interconnectors. Now that's a theoretical case. Today, and Rory will present on it later, we're probably seeing something around 50% export on the interconnectors. That still solves about 1/4 of the problem as a single measure. The question I have is, in terms of market design, are we sure that the market is functioning well and incentivizing on a first principles basis the right behavior on the interconnectors? So interconnectors today help, but I think maybe with better market design they might do more. And I would say with interconnectors, they come with a risk, because it's not impossible that it could be a lot less than 50%. It's not impossible you could even be importing. So we have to be careful when we're considering interconnectors. But to kind of summarize the key ingredients for success, so you need healthy development pipelines on and offshore, and we will not get to this number without both on and offshore. And I've just thrown out a few of the kind of key stakeholders there, but certainly industry is putting its hand in its pocket. It's investing heavily to deliver these projects. You need timely grid connection offers. There's a role there for CRU, for ESB, for EirGrid. We need to manage curtailment. We need to manage constraint, which is the parallel development of the transmission system. We need regular route to market. So if we've got infrequent auctions, or there's not a very active corporate PPA market, you'll have these long gaps while you're waiting to secure route to market, and that, from a timeline perspective, is a big problem. So there's a role there again for the department, EirGrid, CRU. From the res auction perspective, I put the IDA in there as a kind of an umbrella for the corporates. And then it's partnerships. And Mark Foley called us out in the EirGrid strategy. We've got to get really good at collaborating. We've got to share information early, because if you're going to parallel all this up, we have to be very coordinated. So we've really got to work extremely well together if we're going to hit this number. But the key takeaways for me, like as you look through the 8 improvements that you need to deliver the pipeline, I think 7 of them are actually not that hard, or shouldn't be that hard. There's nothing fundamentally terribly difficult about it. The tricky one, the toughest nut to crack if we're going to get to 70%, is creating the space on the transmission system. And as we think about that, it's very important that we don't think about 2030 as a finish line. I think that was maybe a mistake we made when we looked at 2020, 40%. There was a view that that's the finish line, we're going to get there, and then the world's going to stop. There's no way that 70% in 2030 is the finish line. We're looking at, and Mary Donnelly actually yesterday gave us an interesting chat about that in terms of what's happening in Europe, a Green New Deal. But the trajectory is very much towards full decarbonisation. And if electricity is going to be a key pillar of that, so you're going to have decarbonising the electricity sector and electrifying heat and transport as a kind of a key enabler of full decarbonisation, you've got to be able to carry the power. You've got to be able to transfer the power. So when we're looking at kind of very long-term projects to develop the transmission and distribution grids, actually, we need to keep that in mind. We're not just trying to do the bare minimum to get to 70%. The things that take a very long time to do, we have to be starting now, or in 2030 we're going to hit a brick wall and we'll be facing a 10 or 15-year solution to make the next steps. So it's really important that we don't get caught in that trap. And then the final one to call out again is just this point again about the collaboration and partnership. And again, Marie Donnelly and Renewable Energy Ireland are working on a proposal to try and pull together senior figures from the regulators, the system operators, department, industry, to meet together reasonably frequently, perhaps quarterly, to monitor progress and kind of check in on that. With that, I'll conclude. I didn't do brilliantly, but I didn't do too badly.
Very good.
On time. So yeah, thanks very much.